Hello students, welcome to my class. I am Megha Chaturvedi. In this class, I will provide the notes and lectures of the topic transducer, generator and DAC, which is digital to analog converter and analog to digital converter. Our first topic is transducer. Basically, transducer converts from one form of energy into another form of energy. The transducer, which converts non-electrical form of energy into electrical form of energy, is known as electrical transducer. The block diagram of electric transducer is shown in below figure. As shown in the figure, electric transducer will produce an output which has electrical energy. The output of electrical transducer is equivalent to the input which has non-electrical energy. The types of electrical transducer are mainly active transducer and passive transducer. The active transducer, which can produces one of the electrical quantities such as voltage and current, is known as active transducer. It is also called self-generating transducer since it does not require any external power supply. The block diagram of the active transducer is this, and the example of active transducer are piezoelectric transducer, photoelectric transducer, thermoelectric transducer. Now, the second transducer is passive transducer, which cannot provide the electrical quantities such as voltage and current in non-passive transducer, but it produces variation in one of the passive element like resistor, inductor, and capacitor. Passive transducer requires external power supply. The block diagram of the passive transducer is from non-electrical quantity in the passive transducer as input produces variation in passive element as the output. And the example of passive transducer are resistive transducer, inductive transducer and capacitive transducer. Now the next topic is signal generator, which is an electronic equipment that provides standard test signal like sine wave, square wave, triangular wave, etc. It is also called as oscillator since it produces periodic signals. The signal generator which produces the periodic signal having a frequency of audio frequency range is called AF signal generator, and the range of audio frequency is 20 Hz to 20 kilohertz. Audio frequency sine and square wave generator, which generates the either sine wave or square wave in the range of audio frequency based on the requirement, is called AF sine or square wave generator. And the block diagram of sine wave output and square wave generator is from the Wien bridge oscillator connected with the sine wave amplifier then to the attenuator which gives sine wave output, and if Wien bridge oscillator is connected to the square wave shaper then to the square wave amplifier, and the output goes to attenuator, it will produces square wave output. It has mainly the two path, which is when bridge is connected to sine wave and attenuator, it is the upper path, and when Wien bridge is connected to square wave and square wave amplifier then an attenuator, it gives the square wave output which is lower path. Now DAC and ADC ICs. What is an analog to digital converter, which is ADC? An analog to digital converter is a digital circuit designed to perform conversion of analog signal into digital data format. It is also known as ADC, which has the essential component in like computer, data processor, and digital communication system. And the block diagram of ADC is this. From this figure, it is clear that input to an ADC is an analog or natural signal, and the output is a digital or discrete time signal. And the SNR of ADC is equals to 10 log electrical signal power divided by noise signal power. And the type of ADC is flash ADC, semi-flash ADC, successive approximation register ADC, sigma delta ADC, pipeline ADC. And the application of ADC are used in various industries and field where analog signal have to be processed, analyzed or transmitted using digital system like computers. Some common application of ADC are listed below. In this field of digital signal processing, ADC are used for converting analog signal obtained from sensor, microphone or other analog device into digital format from processing them using digital processor. The audio processing application ADC are used to convert analog audio signal into digital format for storage, manipulation and transmission in digital system. ADC are essential components in which data acquisition system used in the field of scientific research, industries, automation and instrumentation. Communication system has ADC are used to convert analog or video signals into digital format for transmission over communication channel. ADC are used in radio receiver for digitization of received radio frequency signal. ADC play an important role in several like medical equipment, healthcare system for converting various analog biosignal and physiological parameter like heart rate, blood pressure, oxygen saturation, etc. Now in the automotive electronic, ADC are used to convert analog signal received from sensor measuring parameters such as temperature, torque, speed into digital format for driver assistance and vehicle diagnostic. Now next topic is digital to analog converter, which converts the digital input into analog output signal. The digital signal is represented with a binary code which is combination of bits 0 and 1, while the analog signal is continuous time function as in sine wave as an example. This chapter deals with DAC and the block diagram of DAC is this. The type of DAC depending on the construction and structure are weighted resistor DAC and R2R ladder. Now R2R ladder, we can recall that the bits of binary number can have only one of the two values, that is 0 1, and let the 3-bit binary input is B2 B1 B0. Here the bits B2 and B0 denote the most significant bit, that is MSB, and least significant bit, that is LSB respectively. The digital switches shown in the figure will be connected to ground when the corresponding input bits are equal to 0. Similarly, the digital output switches shown in the figure will be connected to negative reference voltage VR when the corresponding input bits are equal to 1. It is difficult to get the generalized output voltage equation for R2R ladder DAC, but we can find the analog output voltage values of R2R ladder DAC for individual binary input combination easily. Now the important parameters comes under the DAC are resolution, the number of discrete output level that a digital to analog can produce is known as resolution. To obtain smoother and accurate analog output signal, the resolution of digital to analog converter must be significantly high. The resolution of DAC is typically measured in bits. Let us understand the importance of resolution of DAC. Consider DAC that can handle 8 bit. It can represent 2 to the power 8, that is 256 discrete output values. On the other hand, if a DAC can handle 16 bit, to represent 2 to the power 16, that is 65536 65,536 discrete output values. Hence the DAC with 16 bit can provide a smoother, more accurate representation of digital signal in analog format as compared to the 8-bit DAC can do. Now the accuracy of DAC is the measurement of how closer is the output analog signal to the input digital signal. The accuracy of DAC is an essential factor to produce highly precise analog output signal. And the power consumption by the DAC during its operation, ideally D2AC converter must be power efficient so that it can extend the battery life and minimize the operational cost. Now the operating speed of DAC represents the rate at which DAC converts digital signal into analog signal. Typically The speed of DAC is measured in sample per second or megahertz. The operating speed of digital to analog converter also determines maximum frequency of the analog signal that a DAC can generate accurately. It is essential that a digital to analog converter used in applications like real-time signal processing, generation of fast waveform, high speed communication, and etc. must have a significantly high speed. Now, the noise performance of DAC represents the amount of noise that can be introduced in the output signal during the conversion process. The unwanted noise can affect the signal to noise ratio and hence the signal quality. Therefore, we should minimize the noise as much as possible to obtain high quality output analog signal. And the application of DAC converter is audio amplifier, playback system, video encoder system, data acquisition system, calibration of testing measurement instruments, motor control circuits, digital signal processor, telecommunication system, etc. This is all about the class. Thank you so much.